When I first hear the word digitalization, I think about the process of turning something that is an analog signal into a digital signal. And this is due to what I learned in my signal processing course at university. So I'm going to start this presentation by briefly discussing about what I know about the analog to digital conversion. And then we will see if that is a proper definition of digitalization. So what is the difference between an analog signal and a digital signal? Well, an analog signal is a smooth, continuous signal. An example of an analog signal would be like a sine wave or a cosine wave. Those are theoretical examples. And a real world example of something analog would be my voice. That would be an analog signal. A digital signal is something discrete and in a form that it can be read by computers. That's the importance. That's why it's important to know how to convert something from analog to digital. So how do we convert from analog to digital? There are basically three simple steps. They are called sampling, quantization, and encoding. And I'm going to briefly walk you through each of these steps. Now, what is sampling? Sampling is basically the first step of the analog to digital conversion. Now, if you Google the word sampling, you'll get many definitions because this term is used in statistics and in other forms. But when it comes to signal processing, sampling is when you turn a continuous signal into a discrete signal, which just means you just extract certain points from a continuous signal. You just take points away. Now, these points have to be taken at a consistent frequency, which means the space between each point should be equal throughout your sampling. And the frequency at which you sample is called sampling frequency. Now, there is a requirement when you sample in terms of the sampling frequency, and this is described by Nyquist's theorem. And Nyquist's theorem basically says in order to reproduce the signal that you sampled, you have to sample it at a rate that is twice the highest frequency you wish to record. So that's just what sampling is, turning a continuous data set into a bunch of points sampled at a consistent frequency. Okay, so the next step of the analog to digital process is quantization. Now again, there's a quantization in chemistry, quantization in physics, but we're interested in the quantization for signal processing. Now, what quantization is mapping a large amount of sampled input values to a smaller set of output values. So how do you do this? Basically, you have to take a data set and decide different voltage levels. This is what we like to call them, voltage levels. So you get each of your data points and you see which voltage level they fall into, like which range they are in. So then you each assign them a voltage level. That's what we call quantization. Now, the number of voltage levels has to be a power of 2 because computers are in binary. Now, the third and final process of sampling an analog signal into a digital signal is called encoding. Now, encoding is just converting data from one form to another. In our case, we want to take each quantized value and convert it into a unique binary number. This is so it's digital and it can obviously be read by a computer. Now, the example on the right here in this slide is a simple 3-bit encoder, which if you quantized 8 levels, you can assign each level one binary number. That's 3-bit. Okay, so now that we are fully familiar with the process of converting an analog signal into a digital signal, is that really all there is at digitalization? Is that what digitalization is? Just turning an analog signal into a digital signal? Well, after further contemplation and doing some research, I believe that the process of converting an analog signal into a digital signal is only a part of digitalization. it's not a perfect definition of the entire concept of digitalization. The process of turning an analog signal into a digital signal is better described as digitization. See, that's where it gets tricky. There's a difference between digitization and digitalization. Digitization is a part of digitalization, in my opinion. Digitization is the whole process we just talked about, turning an analog signal into a digital signal. So the next step here is to get a proper definition of digitalization. So what really is digitalization? You see, after doing my research, I've found out that unlike digitization, which is the concept we talked about in the beginning of this presentation, digitalization is actually a very subjective and broad term. And there are many different definitions out there. See, if you Google digitalization, you won't just get one consistent definition, you'll get a bunch of different definitions. So I've decided to come up with my own definition of digitalization and what it means to me and what I think digitalization is. So here is my definition of digitalization and what it means to me. Digitalization is the concept of turning aspects of life into a digital computerized form. So let me break this down. Firstly, digitalization is a concept. This means it's an abstract idea or a general notion. It's not a specific process like digitization, which we covered earlier. This is very important to know. So continuing on, it's a concept of turning aspects of life. So what do I mean by aspects of life? Well, I really mean just any part of a human being's life or anything a human being would do, whether this be like a social interaction or a piece of information or a business model somebody created, just any concrete real life thing. So digitalization is the concept turning an aspects of life into digital computerized form. What do I mean by this last part? So we already know what digital means. Computerized means it is converted to a system that is operated or controlled by a computer. Or if it's information we're talking about, it means to convert information to a form which is stored or processed by a computer. So computerized basically means to make something accessible by a computer or used by a computer, or make something so that it can be done by a computer. And by computer, I don't just mean personal computer, I mean any device that stores or processes data. So phones, tablets, and even like microcontrollers also count as computers. So this is my definition of digitalization. Now, to help you further understand my definition, I'm going to give you some real-world examples of digitalization. First, we start with Netflix. Everybody knows what Netflix is. Netflix provides a service that lets you stream movies and TV shows. So what Netflix has done is that it has effectively digitalized the process of purchasing movies and watching them. Now, it hasn't digitalized movies themselves. Movies were made digital in the early 2000s, and that's when people started purchasing DVDs and whatnot. Netflix digitalized the process, because really before Netflix, people would physically go into a movie store like Blockbuster or whatever and buy physical DVDs, take it home and watch it. Now with Netflix, people can do that by just using a computer or a tablet or a mobile phone. They don't have to leave their phones or anything like that. So Netflix took a real world process of getting movies and buying them and then watching them at home, and completely digitalized it and computerized it in a way that it can be done only using a computer. This is a really popular example of digitalization. Here is a graph showing how the consumers in the UK are spending more money on digital video entertainment since 2015. Now, this graph is just one piece of evidence showing the effects of digitalization on the movie industry. Here is another great example of digitalization. This one takes place in the health industry. Pfizer is a pharmaceutical company and they are working with IBM to plant sensors and mobile devices that will collect patient data for Parkinson's disease. Then, through machine learning capabilities, disease symptom information will be given to doctors and researchers in real time. This new innovative system is called Blue Sky. This entire system basically digitalizes the diagnostic process. So doctors can use a computer to see the symptoms instead of performing physical tests. This also digitalizes the process of collecting research, as sensors and mobile devices are giving researchers data in real time. Here is a short clip that explains this perfectly.
In the past, one would typically do a clinical exam. In contrast, if you were to actually deploy technology where the patient is living in their home, in their work environment, what that allows the patient to do is actually report on a minute-by-minute basis exactly what is going on.
We're going to be using wearable sensors and ambient sensors, and these contain accelerometers, gyroscopes, and magnetometers.
So we may have a sensor with pads underneath the chair that someone's sitting on, so we can see if they're squirmy or not. We're getting data from a sensor that says this is the way the body is moving in terms of.
Our final example is DigiBank. This is a banking company in Asia that is entirely digital and internet-based. This is a very obvious example of the digitalization of banking. Here is an ad for DigiBank showing how digitalized banking saves time.
The game lasts 90 minutes, but I need only 90 seconds.
In conclusion, to me, digitalization is the integration of technology into our everyday lives. It is happening at a rapid pace and is changing the world. The effects of digitalization can clearly be seen in healthcare, transportation, manufacturing, banking, and many other industries. Thank you very much for your attention.